Question 231, day 1 is titled Conditions for Triangle Similarity. Just like last chapter, we did triangle congruence. Now we're going to talk about triangle similarity. And so we're going to answer the question, what information do I need in order to get triangle similarity? So question 68 says, how much is enough? All right, so Ario thinks to himself, there must be an easier way than measuring all three of the angles and all three of the sides to determine if two triangles are similar. What if I only know that all of the angles are congruent? Would that mean that the triangles are similar? So for part A, it says, before experimenting, make a prediction. Do you think that two triangles must be similar if all three pairs of corresponding angles are congruent? And write down the prediction, or write down your prediction and share it with your teammates. Okay? So you should have something like, I think that all the angles must be congruent and all of the corresponding sides must be proportional. All right? Part B says, experiment with Arlo's idea. To do this, you can use the E tool, and I'll have you guys do that in a minute, on CPM, or straws and protractors, we're going to use the E tool, to make a triangle with the angles 38 degrees, 62 degrees, and 80 degrees. Can you make another triangle with the same angles that is not similar to your original triangle? Can you create any two triangles with the same three angle measures that are not similar? Investigate, sketch your shapes, and write down your conclusions. Okay? We're actually going to use the E tool for the next one. It says part C, describe a sequence of transformations to show that two triangles that have the same three angle measures are similar. So I'm going to pull up the E tool. I need to switch this. We're going to switch to the other camera for a second. Maybe. All right, so we are, and that is not going to work. Okay. All right, so which one was it? I have to find the right one. Make sure I get the right one. Okay, part C. All right, so we have these two triangles. So we have angle A, which is blue on the left, that's 62 degrees, and angle D on the right, which is in blue, and it's also 62 degrees. We have angle B over here, which is 38, angle F over here, which is 38, angle C, which is 80, and angle E, which is 80. All three angles of the triangle on the left match all three angles of the triangle on the right. You guys see that? So all the angles are the same. So now we're going to look at their side lengths. Do they look the same size? Does the triangle on the left look the same size as the triangle on the right? No. On the triangle on the left, side A is, over here, is 7.2 units. That's what I'm highlighting. And then side B over here is 5 units. And side C is 8 units. If you compare that to the sides of the other one, they're all going to have this same ratio. So if you take the 7.2 to the 9.4, and you divide it on your calculator, you're going to have a ratio of 0.8. You wrote it as a fraction, it would be 8 over 10, right? 8 tenths. You're going to have the same ratio of the B to the E. You're going to have 5 units. Oh, it's here to here. 5 units and 6.5 units. And then for the last one, you're going to have 8 units to the 10.5. Notice that all three of these ratios are the same, okay? So they all stretch the same amount. If I grab this the other triangle is going to shrink in comparison, or move in the same ratio, so that the ratio always stays the same. Okay? I'll let you guys play around with that in a minute. Okay, now I need to switch it back, I think, to the triangle, or to the paper. Okay, sorry, this is giving me technical issues here. Describe a sequence of transformations to show that the two triangles have the same three angle measures and they're similar. So for the one I just showed you on the E tool, we did a reflection followed by a dilation. So that triangle was flipped over and then it was moved slightly. Okay? Question number 69 says, Scott is looking at the triangles below. He thinks that triangle EFG is similar, and this little symbol is similar, not congruent. The congruent has also the equal part, to triangle HIJ. But he is not sure that the shapes are drawn to scale. Part A says, are the corresponding angle measures all equal? Convince Scott that these triangles are similar. Okay? So for the first triangle, this HIJ, we have an angle measure of 68 degrees and an angle measure of 87 degrees. For this one, we have 87, which matches, but then we have it's 25. That doesn't match, right? But we know of something called the triangle sum theorem. Triangle sum theorem says that triangles have a total of how many degrees? Hint, 180, right? So if you start with 180 and you subtract the two measures that you know, you can get the third angle. So in this case, this third angle would be 25, which is going to match up with this one over here, right? Same thing with the second triangle. If you subtract the two that you know, you're going to get 68, which would match up with the one over here. Do we need to do that for both triangles? No, because if we just do it with the first one, we know that it's 25. That's going to match up with that one over there. So we don't need to do it twice like we did here. We just need to do it with one because we'll know that the thirds angles match up. So for part B, it says how many pairs of angles need to be congruent to be sure the triangles are similar? Why? And how would you abbreviate this similarity? We only need 2 pairs. 3 pairs is great, but we only need 2, right? And so this is called angle-angle similarity. And we use that little wavy line. So we say AA similarity. Angle-angle similarity. Right? Any questions on A or B there? Okay, flip over to the top of page 19. At the top of page 19, it says, question 70. After investigating the AA triangle similarity, Carlos asked, what if we only know that one pair of angles is congruent, but the two pairs of corresponding sides that make the angles are proportional? Does that mean that the triangles are similar? So we're going to use the CPM tool again, the E tool, and we're going to test with 2 pairs of corresponding sides that are proportional with the included angles congruent. We're going to create a triangle with the side lengths of 4 centimeters, 5 centimeters, an angle of 20 degrees between these 2 sides as shown at right. If the second triangle has an angle of 20 degrees and the 2 sides of the angle lengths have proportional to 4 centimeters and 5 centimeters, we're going to try 8 and 10. How do you get 8 and 10 from 4 and 5? Times 2, right? So we're going to multiply by 2. Is the second triangle always similar to the first triangle? That is. is it possible to make a second triangle with two side lengths proportional to 4 centimeters and 5 centimeters and an included angle of 20 degrees? That is not similar. Okay? So again, so part B says, test your ideas from part A on the triangle below. Is it possible to make a second triangle with two of the sides proportional to the given side lengths and with the same included angle? That is not similar. Practice with your E tool. I'll let you guys practice in a minute when we get into groups. And the answer is all of them will be similar. Okay, you'll be able to stretch them and see when you go to the E tool. Okay? Part C says, based on your investigations from parts A and B, what conjecture can you make about two triangles that have two pairs of corresponding sides that are proportional and the included angles are congruent? Justify your response with transformations. So the answer is they will all be similar, and you can rotate them, you can translate them, you can reflect them. Then there's going to be some sort of dilation, growing, shrinking, okay? Multiplying by 3, dividing by 3, multiplying by 8, dividing by 7, whatever your dilation is, okay? Making it bigger or smaller. How can you abbreviate this triangle with triangle similarity condition? This one is side, angle, side. Side, angle, side, but not congruence. You just use the similarity. Okay? Question 71 says, what other triangle similarity conditions involving sides and angles might there be? So which ones might happen? With your team, list other names of every other possibility or possible triangle similarity condition you can think of that involve corresponding side lengths and angles. So you might have angle, angle, side. We know that one's a congruence, so it might be a similarity as well. Side, side, side. Would side, angle, angle work? Would side, side, angle work? Would angle, angle, side, side work? Would angle, side, angle work? Are there others that you can think of in your group? Okay? So we're going to